Our next speaker is Steve Allen. He's Vice Chair of the National Association of Pipeline Safety Representatives, and he's Director of Pipeline Safety, Indiana Utility Regulatory Commission.
Good morning, everybody. All right, good. I only saw a couple of folks nodding out there earlier, but I'll put you to sleep, trust me. A couple of things I'd just kind of like to reiterate what Steve had to say about, we're here to learn. We were asked, NAPSR was asked to participate in this and give our perspective. Okay, so you're going to hear an awful lot of the same sort of theme as what Steve had as well. So to start off, most of you probably know what NAPSR is or who NAPSR is, but just to give everybody a quick overview. NAPSR is an organization that is comprised of state pipeline safety programs from all of the lower 48 states, as well as Puerto Rico and Washington, D.C. The members, through a certification agreement with the Department of Transportation, we have jurisdiction and oversight responsibilities of intrastate pipelines, which many of you know with the distribution systems out there, it comprises the vast majority of underground facilities in the country. NAPSR provides a venue for all of its memberships to collaborate, to get together to discuss new and emerging concepts, risks, regulatory responses. We have a number of standing committees and task groups based on areas that we're asked to research. We have regional meetings, we have national meetings, and basically NAPSR is all about safety, and we are at the state level. We talked about risk modeling, but I wanted to briefly provide this definition of risk management. And as was mentioned, risk modeling is a subset of risk management. But generally, risk management is the systematic approach using policies, procedures, controls, and applying limited resources to make sure, through modeling, to make sure that risks are identified or threats are identified, assessed, and controlled to protect people, property, the environment, and pipeline facilities. Okay, so here comes the NAPSR perspective. First and foremost, and you're going to hear me say this a number of times, and I think we actually heard it already this morning, operators must know their systems. This is a primary expectation for state programs. If you don't know your system, who will? So that's kind of the number one or primary expectation of states. Risk models should be rational. They need to be logical. They need to make sense. Risk models must be fully documented. And this helps to ensure understanding of your risk model for continuity's sake, for consistency, and for compliance. Then risk models should be validated for reasonableness, and by that I mean that they need to be, the output of the risk model needs to be reviewed by experienced, knowledgeable personnel, subject matter experts, to determine whether or not the output of the model actually makes sense. Risk models should be data-driven. They need to integrate data from multiple resources. They need to be complete. There's all sorts of information that you have available to you out there, and it needs to be incorporated into your thought process or your risk modeling process. Lack of data can affect the type of model that is used, obviously. GIS should be incorporated into modeling. It's a very visually powerful application. When you bring the many different data sources together and plot them on a GIS, you get a whole new perspective. Many of you probably already do that. And actually, I'd be curious to see a showing of hands of operators that do incorporate GIS into their model, please. Well, not as many as I would have thought, but that's good that you are. Data quality is imperative to effective risk modeling. The accuracy and the integrity of it. I think Steve mentioned garbage in, garbage out. True words were never spoken. You need to have controls in place to make sure that the data that you are using in your risk model is accurate and it's relevant and it's consistent. Risk models must be dynamic and consider new or changing information as discovered. Again, you're going to hear a lot of repeating themes. I mean, Steve mentioned all this, so this is like a summary in part of his presentation. Talking about the risk models needing to be dynamic. Threats and risks can change overnight. What you thought was not risky today could be very risky tomorrow. So your model needs to be nimble enough in order to take that into account. From a state regulatory perspective, as an example, we are required to have a data-driven, risk-based approach in how we go about conducting our inspections. And there are certain prescriptive time frames that PHMSA has for us to complete certain inspection work. But as an example, with a small operator, talking about how risks change on a dime. With a small operator, if we have an individual who is a key member of the management team, who really is the only one that knows what's going on, and frankly, there are lots of very, very small operators out there where that's the case, where there's one person, just one person that really knows what's going on. If they leave and go to work for a larger operator, or go to wherever, all of a sudden the risk for that operator shoots up, and that is a trigger event for us. Where when we hear of that, it's almost as if we drop what we're doing and we go meet with that operator. So we're trying to be nimble in that regard. Continuing with risk models being data-driven, risk models need to, as I mentioned, react to new and changing threats. Natural disasters, as an example, no one can necessarily know what's coming. You're going to have changes. You're going to have changes in your threats or your risks associated with events that you just may not have considered. Gap analysis must be performed to identify missing data. If you don't know something about a part of your system, then your system needs to acknowledge that. Your model needs to acknowledge that, and then you need to be conservative in that. In other words, if you don't know something, that doesn't mean it's not a risk. That's from our perspective. Just because you don't know it doesn't mean it doesn't exist. So plans need to be developed and executed to obtain that missing data, such as just like what we have in DIMP. On threats, operators are expected to identify and incorporate all threats into the risk model. Again, operators must know their systems. Need to consider the 9 threat categories. Operators must understand the risk model. Know what changes in input can do to your output. Data integration is key to a robust model. As new data and information or insight is obtained, it needs to be integrated into the model. It needs to, again, not be static. It needs to be dynamic. And as I mentioned before, lack of knowledge does not justify threat elimination. We can't be ostriches. We can't bury our head in the sand. Just because we don't know something about the system, or we don't know a threat, or we don't know information about the threat, we can't eliminate it. And minimization of threats by operators must be fully documented and supported. You have to justify why that risk is being minimized. The risk is never eliminated. You can minimize it, because a threat that you don't think is a threat today very well could be a threat tomorrow. So it's never really truly eliminated. I did mention threats can and do change over time. Interactive threats must be considered. System or pipeline-specific threats, localized threats. In addition to, some of the threats that we'd all know about from reading technical literature and involvement with trade organizations and whatnot, there's also specific threats that are just local. You have one bad excavator out there that just keeps hitting your line or whatever. There are specific localized threats. And lastly on this slide, risk models need to drive the preventive and mitigation measures. So, your output from the risk model isn't just to have output from a risk model. It's supposed to drive decision-making at the management level. And what do we do first? And I said before, it needs to be nimble enough to react to new and changing threats. Operator personnel. They must be experienced and knowledgeable. They need to know what they're doing. They need to be aware and knowledgeable of your system and your operations. They need to understand risk modeling, and your risk model in particular, how it works, how it reacts to changes in the model. You tweak an input over here, what happens over here, and then the operator personnel need to know how to recognize data discrepancies, errors, unacceptable variances, gaps or holes, and you should have controls in place to ensure that those discrepancies are identified and the procedures in place to respond to those. This is an interesting one, and I had an opportunity to visit one of our larger operators here recently, and they walked me through their risk model. And it's very good, but it was very complicated for a novice such as myself. NAPSR believes it is important that operators need to consider the implications of model complexity. The more sophisticated or complex that the model can be, the harder it might be to understand for new employees coming in to help run the process. It's more difficult to manage, and there's more opportunities for failure or for misses. All right, a very complex risk model that perhaps isn't as well documented as it should be can lead to poor decision making, we believe, and you can end up actually not seeing the forest for the trees. On the documentation of the model and decision making, it's really imperative. It's imperative for continuity and consistency of the application of the response, the P&M measures to the output of your risk model. Documentation is imperative for continuity and documented institutional knowledge that will have been built up over time, which is very important to succession planning, which I see a lot of gray hair in the room, so I know succession planning is at the top of everybody's list. Evaluations of programs. Programs need to be reevaluated regularly to determine whether or not the risk model is still appropriate. I mean, is there a better approach to what you've been using? All data integration, all relevant data, information, knowledge needs to be incorporated. Again, a repeating theme. Effectiveness of the preventive and mitigation measures. You need to be able to draw a line in the sand or have a baseline where then you have output from a risk model, you implement P&M measures, you go back to see whether or not what that did to your risk. Are your P&M measures actually effective in reducing risk? And then here's a concept from, and I'm going to talk about on the next slide, is the pipeline safety management systems. Plan, do, check, and adjust rather than act. So evaluation is your program. It's the check part. So plan, do, check, adjust. Speaking of pipeline safety management systems, it's our belief that risk modeling is is part of safety management systems, and safety management systems is part of risk modeling. Risk modeling, you need to incorporate some continuous process improvement. You get feedback on how the process worked, you implement changes to the process, and you move forward. It's a big control cycle, contemporary management practice that needs to be applied to risk modeling. Risk management must be incorporated into operators' daily activities and the safety culture. Stakeholder communication channels must be supportive of risk models. The folks in the ditch, they'll see something that they know is a risk. And unless you have a safety culture in place to direct that individual to report that information upwards, and that individual has the confidence that if he reports something that he sees upwards, that something's going to take place, something's going to happen. So safety culture might be a tough sell on how this all relates to risk modeling, but I assure you it's an integral part. So conclusion, risk models must be data-driven and objective. Risk models must consider all threats. Anything that can go wrong in your system needs to be taken into account. Risk models must be rational and documented. Risk models must drive P&M measures. Operator personnel must be qualified, and pipeline safety management system concepts must be embraced. And lastly, operators must know their systems. Questions? I guess we're having questions later, so thank you.
Okay, thank you, Steve. We're going to go on.